All right. Welcome, everyone. Thank you for joining us today. We're from Sonrai Security. We're here to talk a little bit about AI and AWS. And Nigel, I think if you wanted to share.
Yeah, let's do that. Let's get this presentation on the road.
Do some introductions, give you guys a bit of a rundown of what we're going to go through today. Largely what Nigel's going to go through today, and what he's going to take us through. If you can go all the way back up to the top here. Oops. That's all right. So AI runs on privileges. What does that mean? Well, all of you, I'm sure, are familiar with AWS. All of the wonderful services in AWS, most traditional ones you've used for years, and now all of these new, I'll say new, some have actually been around for quite a while, that fall into this AI realm of services that AWS offers us, and how that all interacts with the privilege aspects of AWS, and what does it actually mean to secure AI on AWS? Next slide, Nigel. Just a round of introductions. I'm Matt Carle. So I do product things here at Sonrai. Speak to customers like yourselves every day about the problems they have with privileged access in their cloud and how can they control privileged access in their cloud. Obviously, we have solutions in that space. We'll talk a little bit about that today at the end, but today's predominantly about what does it look like to have AI in your cloud and what can you do to secure it. With me is Nigel, Nigel Sood.
Yeah.
He's our cloud privileged threat researcher. Say hello, Nigel.
Hello.
A little bit about yourself.
Yeah. I've been spending a lot of time recently digging into identity and access management in public cloud, particularly with regards to a lot of these AI services and looking at all the different ways that identity is used and how identity can be misused in the cloud. And so some of the information that I've been digging up over the past few months is what we would like to bring to light today.
Awesome. So just a brief rundown of what we're going to go through today, ladies and gentlemen, is AI and AWS. What is it? What does it look like? Securing AI and AWS, identity in AI, or identity and AI. Obviously, we here at Sonrai spend an awful lot of our time focused on what does identity do in these cloud environments and how can you control it. So we have a particular point of view on identity, especially as it relates to AI, agents, and how can this all go wrong. And then things that we can do in some policy samples. Nigel's actually going to get a little bit technical on us here and show us a few things that can be done. Some of the things he's found during his research and some things that you can take home with you and use today to actually start, improving that posture in the cloud around AI, especially as it pertains to identity.
Exactly.
Next slide, Nigel. So Nigel, first I wanted to say welcome. Thank you for joining me. We're going to again talk about AI and AWS, but I wanted to get us all on the same page first. So AI for me is every day now. I use AI with Claude. I use AI with ChatGPT. I use AI with Perplexity. It's in almost every aspect of my life now, as I'm anything from Googling what I should or using Google to get ideas, may take those types of searches now and go to OpenAI and say, here's what's in my fridge. What should I make today? So the world's got me thinking about AI, and the words like Claude and ChatGPT and all these LLM solutions come to mind. But I feel like that's not what we're here to necessarily talk about. So help me understand AI and AWS and what exactly are we going to talk about today?
Yeah, so AI and AWS is a really broad topic. And like you can see on the slide there's 40 plus services in AWS that deal with AI in some capacity or another. And there's a few different categories of it, but the ones that have really kind of come to light recently and the ones that are really prominently used right now are the ones that have to do with, agentic AI, agent orchestration, scaling, that sort of stuff. But really there's quite a number of different things that are available. And a lot of these have been around for a while. We've got some examples here. Something like SageMaker has been around for ages. It's been around for years. A lot of this stuff is relatively new. And you've got these different categories of things. You've got stuff for AI infrastructure like Bedrock and Bedrock Agent Core. Agent Core just dropped a few months ago. You got stuff for productivity, things like Amazon Q. That's like your equivalent for Copilot. You got stuff where it's more kind of canned solutions to specific problems, stuff like recognition, to do things like image recognition, voice recognition, that sort of stuff. And then your model specific, more LLM specifically than AI in general stuff like SageMaker for model training. There's a bunch of different types of AI services. We're going to be focusing today mainly on the AI infrastructure stuff because that's what's becoming really, really important, today in cloud and AWS, but all of this does exist.
Excellent. Next slide. All right, so I think I get it. We're here to talk about all of these AI services and how I, as a user of AWS, can consume AI to both, for my own use, potentially, but more likely how I as a user use AI services to augment a product that I'm delivering to my customers, how AI sort of folds into our enterprise business, right? And how we're actually going to protect that. Now, I did some searching before this, and obviously AI has been, it's kind of ubiquitous these days. So we're talking about it all the time. The world and the internets would have me believe that, I should really be worried about things like data poisoning and model evasion and all of these model style attacks or model level attacks and model level security measures. And I'm sure these are important, but I think you're implying actually, Nigel, is there's something else that I need to focus on, specifically when I'm taking AI into the cloud realm and dealing with this AI infrastructure that's part of my business and part of what I deliver, and in securing that to ensure that it is safe and secure from exploit.
And I think that's 100% right. The model level security concerns are real. In the past few weeks, I think I've seen almost every day, like a new report on some new thing where some company has found some way to compromise, some SaaS type AI product through prompt injection, that sort of stuff. It is real. But when you're hosting AI in AWS, particularly you're hosting it on infrastructure that you're controlling in AWS, there's a level that you need to address first. And that's the infrastructure level. If you're going to be hosting your models on compute resources and you're giving them access to tools in AWS, you need to make sure that not only is the model secure, the thing that's going to be facing the public, but also that the infrastructure that it's being run on is also secured. And, if you want to, put in good solutions to control that model level security, the cloud has that. AWS, particularly in Bedrock, looking at things like guardrails, it gives you the solutions that you need to implement some of that model level security. But because those tools are cloud native, you need to be able to control the access to that, to those cloud native tools in the first place. If you've got stuff like Bedrock guardrails that you're using to secure your Bedrock agents, you need to make sure that you're controlling the permissions to access those guardrails to make sure that the solutions that you're putting in place for that model level security actually stay in place. If you're using cloud infrastructure for model level security, unless you control access to that infrastructure, you're going to get nowhere.
Gotcha. Okay. So that leads us to the next question. Where does identity fit into AI? I think when people hear identity, they think about all these humans and service accounts and things like that, but it seems like it might be a bit more complex. Can you help me understand how identity in AWS plays into the AI story?
Yeah, and I think you've got half of it right there. And it's that, you have users, you have non-person identities, identities associated with compute. And basically every time anybody, be it something that exists infrastructure-wise in the cloud or somebody outside of the cloud who's accessing it, a lot of that access is done through identity. That's kind of the gateway when it comes to public cloud. You do things through permissions, not through network access. So when you need to access AI resources, or when you have AI resources in the public cloud that need to access other things, it does it through identity. And so basically every agent that you have, or even if you're using productivity tools like Q and you're using Gen AI to access other cloud resources, it's going to be doing it oftentimes through some sort of identity and access management privilege. And different services gain privilege differently. You've got productivity tools like Q, where if I'm using it, it's very Copilot-esque in that it can do what I can do. Where if I ask it to go hit the AWS control plane and go figure out what S3 buckets I've got in my account, it's only going to list the things that I myself have permission to access. So it inherits permissions from the user. A bit of a more difficult case to handle on security-wise is something like Bedrock and Agent Core. Those are a little bit different in that when you've got AI resources that are kind of stood up on their own and you're interacting with them as a user, you're often giving them their own identity and access management roles, and then they'll act on the permissions that they're given to respond to the requests as they come in. So agents are basically identities that act on your behalf, and sometimes the privileges that they're given and the privileges that they can use to perform the tasks that they've been given are overscoped, and then you start to run into identity problems.
Excellent. So this is actually far more nuanced than I expected. So we're dealing with some identities that are accessing the infrastructure and doing things and configuring the infrastructure, but then we're also talking about all of these probably non-human identities running around with permission, and they're acting actually on behalf of the models. They're taking action not necessarily because a human told them to do something, but because something a human said or asked a question in a certain way, a model may react and then cause this agent to do things using permission in my cloud.
Yeah.
Is that the case? Like it seems like there's actually two scenarios here.
Yeah, and that's exactly right. If you're trying to lock things down at the identity level, you need to be controlling both what can access your AI resources, so securing access to your AI resources, but also securing what those AI resources that often have their own identities can be accessing. It's kind of a two-step problem that you've got to solve, and you need to handle both sides of it. Otherwise, you're leaving open potential for misuse, either by coercing your AI resources in the cloud to perform actions on your behalf that you might not be able to do yourself, kind of a bit like a confused deputy, or you're allowing people to direct access to AI resources, either to the tools or to the security features that you're building on top of your AI resources to protect them. And anybody with the wrong access to those AI resources could potentially start tearing that stuff down. So you need to solve both of those problems. Otherwise, you're going to run into problems. And we're talking a lot about identity, but in public cloud, identity is the means by which you do all this stuff. If we were, hosting our models locally, we'd be doing all this through network controls, and securing access to the servers that are hosting the models and all that stuff. The reason we're harping on identity is not because identity is necessarily inherent to AI, but it's inherent to AI in the public cloud.
That makes sense. Can we talk a little bit about this securing access to my AI resources or of my AI resources?
Yeah, sure. So we've got some examples that we're going to run through. The first one, I'm going to go a little bit from kind of simple to a little bit more complex, but we're going to look at both sides of that equation. So starting with securing access to your AI resources, your really dead simple example is talking about some of the security features that are provided cloud native through AWS. And you'll notice from here on out, we're going to really focus this presentation a little bit on Agent Core and Bedrock specifically, that AI infrastructure category of AI services in AWS. That's not to say that identity is not important in any of those other categories whatsoever. It 100% is, but it's such a vast topic that we need to kind of keep ourselves focused for this presentation. So we're going to be focused on Bedrock going forward just for these examples. But our really easy place to start is, when talking about securing access to AI resources, talking about those security features. So I talked about how you can use things in AWS like Bedrock guardrails to implement some of that model level security. And this is kind of what it looks like when you're setting it up in the console. You've got a whole bunch of different types of categories of conversation and content that you can start filtering on. So if you want to host, some sort of professional chatbot that you're going to exposed to the public, there's often a lot of these categories that you're not going to want that model to be able to act on. You don't want it to respond to anything hateful. You don't want it to respond to anything, insulting or generate insulting content. And you can configure these filters to act both on inbound and outbound content. You can use these guardrails to filter for personally identifiable information on the way out when the model's returning something. You can also create your own custom list of topics that you don't want the model to be able to talk about. It's a super versatile tool, and it's super useful for helping secure these agents and securing access to the core LLM models. But the guardrails are only useful as long as they stay in place. And so using some identity and access management permissions, if these are overprivileged, say, this is stood up in an account and you've got a junior dev with administrator access, they've got star permissions, and they can come in, and you've got somebody who's a little bit immature and they want to go to their friends and say, hey, look what I can make our company chatbot do. So they go and modify these guardrails a little bit. You're opening yourselves up to a bunch of liability by doing that. And it's through the identity and access management permissions that this is happening. Somebody with this Bedrock update guardrail permission can go and take all of that model level control that you've put in place and really fine tune to allow the model to only talk about the topics that you want it to talk about and not go way off the rails with inappropriate content. Somebody with this one permission can go and take all of that effort away.
It's interesting. I just a case in example of this. It seems logical, and it seems like, of course, we would control this access. Was working with a customer a couple of weeks ago now, and we were dealing with a scenario where they actually had a third party that has been given access to parts of their cloud. Their data science teams working in AI, we're looking at partners to partner with in the AI realm. And like we're known to do, we run some Terraform to get new roles into our cloud to allow a third party into our world. And lo and behold, we had a third party with access to the model accounts and the parts of the infrastructure where all of this company's AI runs. And those were completely wide open admin level privileges granted to a third party. And so without even, I wouldn't even say it was just sort of, it just happened. And we see this all the time. It just happens, right? And we end up with this type of access, which, hasn't been used to do the bad thing, but boys, if that third party got breached, your whole world becomes a target for all of anybody who knows that you were working with them and can come through that third party into your world now and then start making changes like this to exploit your infrastructure and your AI infrastructures. Anyway, just a real world example.
Yeah, and this is kind of the easiest thing to point to and say, hey, there's a privilege problem in Bedrock. If you overprivilege certain things, this is the the result of that is all of your model level security can start to fall away. There's also some more nuanced cases as well, like our next example.
Yeah, this one, I find this one really interesting because we've been very much watching what goes on in AWS and the other clouds as well around the AI services. And this we were talking about actually not that long ago when Agent Core was released. Nigel started digging in. You were writing a blog on this. I think this was very much in that realm of protecting AI infrastructure, but maybe a little bit more complicated or a little bit more interesting about what I could actually get this infrastructure to do on my behalf if I wanted to. I just wondered if you could share this story.
Yeah, absolutely. So Agent Core, just for some context, came out a few months ago, and it's the service that AWS created to make it really easy to scale agentic AI, to be able to scale things up, to be able to orchestrate it, and to be able to separate the agent definitions and then the actual computes that those agents are running on, separate that out from all of the tooling that you want to build around it to make it a little bit easier to access. And when you start to separate the tooling from the agents, now all of a sudden you have agents that are needing to talk to another AWS resource, and that happens through identity. And whenever you have a compute, whenever you have tooling that this AI is going to use, and it needs to perform some sort of action that potentially has access to other cloud resources, that also needs identity. And so you've got, situations where if you're using Agent Core the right way, or maybe the wrong way, you've got AWS resources that have computes that can do things that agents are telling them to do, and they have, those tools have their own privileges that they can use to perform actions. And what we started thinking about was, well, I wonder if we can just start pinging those resources directly and have them use their privilege to do things for us. And it turns out that that's exactly the case. There's a handful of Bedrock permissions that you can use as a mechanism to pivot to a more powerful.
So we think it like this is very much a confused deputy style scenario.
Yeah, basically. And really it's, a focus on the AI resources and not necessarily the models themselves. The example, we're going to go through a live demo in just a second, but the example that we're dealing with here doesn't touch any models at all. It doesn't touch any agents at all. It just has to do with the AI infrastructure that exists in AWS to help support these agents. So I'm going to pop out of this presentation and just pop over to our console with Agent Core. And just for some context, we're going to be looking at the provided cloud native tools that exist in Agent Core. There's also this concept of gateway in Agent Core, or these concept of gateways where you can, configure your own MCP servers to go and allow agents to go and talk to them. But we're going to be dealing with the stuff that AWS gives us out of the box and these built-in tools. So when you create an agent in Agent Core, you can configure it with these built-in tools to either give it browser access or give it access to a code interpreter. And that's what we're going to be focusing on here. These code interpreters could be used if you want your agents to be able to run code as part of responding to prompts. And so if you stand up your own code interpreters with the intent to later attach them to agents and let them run code, one of the things that you'll notice you can do very quickly is you can give them an identity and access management role. And so the goal here was to figure out, hey, maybe if I can access this code interpreter directly without having to go through an agent, maybe I can go from whatever Bedrock permissions that I have to whatever permissions this code interpreter has. And it's really, really easy to do that, believe it or not. So, if we take a look right now, we'll open up Cloud Shell, start a new session. And you can see right now, I've got this role called Bedrock Agent Core Dev role. And if we, run some commands in here, you'll see that that's what we've got. And, my Bedrock role right now has, relatively few permissions. I can try and list the S3 buckets in my account, and it's not going to work because I don't have the right permissions for it. And you'll see that I don't have the right permissions, so I get an access denied. But I do have access to all the Bedrock resources in my account. And so I'm going to try and leverage this custom code interpreter. Now, code interpreters in Bedrock Agent Core, you can't invoke with the CLI directly, but you can do it through Boto 3 and you can do it through direct API actions. So I've already got this Python utilities file that has all the stuff that I need, and I'll show you what's in it, but it's not super important. It's really just this dead simple function. And don't worry too much about the code here, but we stand up a session with the code interpreter, and then we define this function that allows us to give it arbitrary code, in this case, bash code, and it'll go and run that in the code interpreter and then just print out the results. So again, the code itself isn't important. It's just the concept of being able to provide code to this code interpreter and then get stuff back. So we'll go into Python and import all of that. And now I can provide arbitrary bash code using that function. So, this is bash, just to make sure this is working. Not print, echo. And it'll go and run that code in the code interpreter, return the results, and print it out for us. Now, talking about identity, the goal here is to see if we can leverage our specific Bedrock Agent Core permissions to go and do something else. So let's try providing an AWS CLI command, see if that works. Now, we need a pager for this to work, but we'll try that same call, get caller identity. And you'll see that despite the fact that I'm pinging the code interpreter using this role called Bedrock Agent Core Dev role, when I provide an AWS CLI command and tell the code interpreter to go and run it, it's actually doing it under the execution role for the code interpreter. So beforehand, where I only had specific access to specific Bedrock Agent Core permissions, if I can access this code interpreter that has additional privilege, maybe I can start doing some extra stuff. Let's try and list those buckets. The thing that I couldn't perform before, now I can do it, and I can see everything that exists in the account. And depending on the privileges that are assigned to the code interpreters, anybody with the invocation permissions for that code interpreter can do whatever that code interpreter can do. And it could potentially be something that I really shouldn't be able to do as a Bedrock developer, like EC2 create VP say. And see if this works. And we've got a new VPC created. And this is something where if I were doing this, using my Bedrock Agent Core dev role, I wouldn't be able to do this, but we've got something new created right here with its new, with all of its configuration stuff and its VPC ID. If I go back out and, I try to do that again from my Bedrock Agent Core dev role, it's not going to work. So the whole point of this was to go through and basically point out the fact that when we're dealing with tooling for agents, it often exists as standalone compute resources that can be invoked by the agents with identity and access management permissions. But if you're not careful about assigning those permissions the right way, anybody else with those same Bedrock permissions, be it agentic AI or be it a user who's trying to misuse these permissions for their own gain, anybody with access to those resources can coerce them into performing actions that potentially hit the AWS control plane itself. And in this case, we were able to use it for privilege escalation. We went from somebody who only had a handful of Bedrock permissions who could invoke this code interpreter to somebody who could list your S3 buckets and create new VPCs.
So let me get this right, just so I understand. We have taken the tools that we were given to efficiently and effectively and securely scale AI and agent-based AI use cases.
Mm-hmm.
And through no real fault of anybody, we've exposed every single identity that's behind a code interpreter to any identity that can simply work with that agent infrastructure at all.
And that's exactly right. And this isn't the first time that something like this has come up in AWS. There's plenty of other cases where this exists too. Any EC2 instance that has an instance profile role, anybody who can SSH into that EC2 instance is going to be able to access the identity there. This is kind of the same thing. But where this is still really new. There's not a whole lot of guidelines around how to use this properly. And, it's a really easy case where one or two badly provisioned permissions in Agent Core can expose a whole bunch of permissions that really shouldn't be exposed to the bedrock users.
Interesting. That's interesting. Thank you, Nigel.
Yeah, and back to our presentation. So yeah, we've talked about how the compute resources can be leveraged to escalate privileges because all of those AI resources that are executing stuff in the cloud or need access to resources in the cloud are going to have identity.
This one's I find interesting though, because this example 3 is really, I call this the movie script scenario of when AI started to really take off. I say really take off, when AI really became mainstream with all of this LLM news and use cases and capabilities. Of course, you start to harken back to the Terminator days of the AIs are going to take over the world. So do I have to worry about the AIs themselves having identity and doing things that they want to do in my cloud? Can they take over my cloud?
I mean, so to some degree, no, but to some degree, yes. So we've talked about securing access to the specific AI resources. This is securing access of the AI resources. So when you have, compute resources or agents that are powered by LLM, and then you start giving them access to permissions and to tools that allow them to use those permissions, they can have a mind of their own in that when they receive a prompt, they're deciding what tools that they have access to they're going to start using. And so depending, and this is where some of that model level security comes in, you're going to want to prevent this sort of stuff from happening. But if you do it at the permission level first and you start looking at what those models have access to, you can start to limit the mitigation, you can start to mitigate the damage that can be done if those models were to become compromised. In this case, we've got not an agent core, but an OG AWS bedrock agent setup. And it has access to a Lambda function that gives the AWS control plane access. And it is really easy to ask it to, hey, go do something in AWS for me, and it'll go and figure out what it needs to do code-wise. You don't need to provide it any Boto3 information. You don't need to provide it AWS CLI commands. You can just ask it, and these are real screenshots of a sample agent that we have set up. This isn't doctored at all. You can ask it stuff like list me the S3 buckets or create me a new VPC, and then you can go and check in the VPC console, and you'll see that it's there. So it's less potentially that these are going to go and start doing stuff, on their own, unless you've got a whole set or a whole nest of agents set up where they're all talking to each other. Maybe you'll end up with some situation where some prompt goes wrong from one agent to another, and it'll, start to think maybe I need to go do this thing in the AWS control plane. But it's also, if you've got stuff with privilege and these agents have access to the AWS control plane, and somehow this gets exposed with your public facing chatbot, or something with access to S3 gets exposed, and the right prompt will tell it to go and use its privilege to go and access storage that it shouldn't be able to and go and pull out sensitive data. It's the privilege of the agents that you need to concern yourself with, kind of on that side of the fence, to make sure that whenever these agents get put into production, whatever role they're going to be performing, it only has access to the resources that it needs to perform its duties, and not do things like listing the arbitrary S3 buckets in your account or creating new VPCs.
I think it's interesting. I mean, just to sort of not really sum it up, but I do think and I won't speak for anybody who's on the phone, but certainly many colleagues that exist in the IT space, building software, doing security. And there's no doubt that we have this vast acceleration of code being generated, Terraform being generated. So while these are contrived examples, and these are contrived examples, we've contrived these to show the impact of what could happen. There's no doubt that there's the velocity at which we're building infrastructure today is far greater than it was even 12 months ago. Mm-hmm. And these mistakes can really happen, and they can really happen based on the fact that it may not even be a human being writing the next thing that goes into the agent as the actual code that the agent runs, or the definition of the code interpreter that gets used, or the actual Terraform that is used to deploy the actual code interpreter's identities and what permissions are in those.
Exactly.
So it's certainly not meant to be a FUD story. There's the reality of this stuff moves now so quickly. These mistakes can just be Tuesday. and we end up with identities in cloud with way more permission than they should have, the implications today with AI can make that actually quite a bit more severe than it would have been in the past. And I think that's the point where Nigel's trying to lead us to. Sorry, next slide, Nigel.
Absolutely.
I just want, let's bring this home.
Yeah.
I think I know the answer, Nigel, but I'm going to ask the question anyway. What's the most important thing that we can start to do as users of AI in AWS to actually secure this infrastructure?
Yeah, so I mean, high level, you want to deal with the infrastructure stuff first, and then once you've got your permissions under control, then you want to go model level. But looking at that infrastructure level, the kind of 3 steps that we've got listed out here are, lock down the identity and access management roles for your agents and services. Thinking back to that last slide where we had agents performing things that they had no business performing, you want to make sure that if you're giving agents privilege, and oftentimes if you're hosting your agents in AWS, you're hosting it there because you want it to be able to access some other sort of cloud resource. Make sure that it only has access to the resources that it needs access to. So that, telling, cloud people do least privilege is, maybe not the most helpful advice, but when you're dealing with agents specifically, often they're only going to need access to 1 or 2 specific AWS resources, and that should be doable for the 1 or 2 roles that you're going to be having associated with those agents. Step 2, use service control policies. The reason I'm highlighting service control policies and not resource control policies is that in a lot of AWS services, like Bedrock specifically, they actually haven't included support for resource control policies yet, or for resource policies. So SCPs are kind of the way to go, at least when it comes to Bedrock. Use those with condition keys, restrict access to the Bedrock tools, and also restrict access to the models and restrict the access that those agents can perform.
Gotcha.
And then the last thing is, continuously audit. Make sure that you know who has access to your Bedrock resources. And, this could be, using CloudTrail. This could be using CloudWatch. There's a whole bunch of monitoring solutions that exist these days, but know who is using it and be able to change those permissions really quickly.
Sense.
And going on to the next bit, we've got a couple of SCPs just to address some of the examples that we talked about before and give you a really easy place to start. These are dead simple examples of SCP statements that you can use. Obviously, if you're going to be implementing this in your own organization, you're going to be wanting to do a lot more than this. But looking at guardrails specifically in Bedrock, something like this will get you most of the way already. You want to make sure that those people who have full administrator access, who aren't necessarily using that to deal with Bedrock resources specifically, you want to make sure that they don't have the capabilities to delete your guardrails or update your guardrails. And so the example here is basically just deny updates or deletes to Bedrock guardrails unless you're coming from a specific allowed Bedrock developer role. And you might want to include some condition keys in here as well to also include your break glass roles. But the idea is that you should have a defined list of who can perform actions on your security controls in Bedrock, and anybody who's not that shouldn't be able to, even if they inherit those permissions from Star or whatever.
Makes sense.
So that's one example. Next example, talking about that Agent Core code interpreter example, make sure that you're restricting access to Bedrock Agent Core invoke code interpreter. That's the permission that gets used when you go and provide code to the interpreter. And the idea here is that if you're having these code interpreters set up, you're having them exist in AWS as tools for your agents and Agent Core to invoke. You shouldn't really be using the code interpreters for anything other than your agents, because anything else is going to have its own identity and its own compute environment with which it can use those permissions. So in this case, you want to set it up so that only those identities that are hard-coded to be used by your Bedrock Agent Core agents, those are the only principal ARNs that are allowed to use the invoke code interpreter permission for specific code interpreters. So that's our second SCP example.
Excellent. Thank you, Nigel. Next slide. This is where I do get to talk about what we do. Obviously, we do find this problem around AI and cloud to be fascinating. However, it's not unique. This exists across every single service in AWS, every single aspect of AWS, and the privileged access that exists in your cloud environment. Obviously, us here at Sonrai, we have built the Cloud Permissions Firewall to fully automate the control of this PAM, this privileged access to my cloud environment or your cloud environment, giving you the ability at the single click of a button to basically do everything Nigel has said today. Really start to lock down these environments and ensure that they're used the way that you intended them to be used. And when they are used in a way that is different than that, getting notifications and understandings and approval requests to why is this agent that exists in my production environment now trying to author roles. It's never done that. It probably shouldn't be doing that. And I certainly don't want it to do it unless I really have an understanding of why. Obviously, we'd love to hear from you guys. Anybody who's interested in solving this problem and all of the other privileged access problems in AWS and other clouds, certainly reach out. We've got 14-day free trials. Click from the website and you're off to the races. You can see how your cloud looks, how it runs today, and how easy it is to lay down these guardrails to ensure that it does exactly what it's supposed to do tomorrow and nothing else. So thank you everyone for coming. I think we'll jump to questions now. Let me see if I close this. So we do have a couple of questions here. Do you recommend running agents and LLM workloads in separate accounts / IAM boundaries for non-AI workloads? Why or why not? It's a good question.
Yeah, it is a good question. I think it really depends on what your use case for AI is. You're going to want it to be in a location. And again, if you're hosting AI resources and you're hosting AI workloads in public cloud, odds are it's because you want it to be able to interact with other things that you have hosted in public cloud. Otherwise, you'd be using some SaaS offering, or you'd be using API keys to OpenAI or to Anthropic. If you're hosting agents there, it's because you want it to be able to interact with other things. And so you're going to need to have it located in an environment with which you can access those things.
Those pieces.
But from a segmentation perspective, it might be smart to take the resources that you want your AI to be able to access and have those segmented along with all of the other Gen AI type stuff in its own AWS account. Or if you want to deal with the cross-account access requirements, then maybe you do want to have your AI resources live in their own account, but those roles are going to necessarily have access to resources in other accounts because, again, odds are the reason you're hosting it in cloud is because you need to access other cloud resources.
And to reiterate your point from earlier, we do still have some limitations around resource policies and resource policy capabilities in AWS, specifically around bedrock and other things. So you do have some limitations available in the infrastructure itself to try and do these isolations.
And the benefit to hosting everything in the same account is that, or even in the same organization, is that SCPs do work. The moment you start separating things, you need to use stuff like resource control policies that I don't think support Bedrock yet, or resource policies in order to lock it down, and neither of those solutions are available yet. So depending on the solutions that you're going to be using to secure those resources, it might be smarter to keep it together because then you end up with those solutions like SCPs that you can start using.
Absolutely. We've talked an awful lot about Bedrock and identity, and Agent Core and identity. I think the last time we counted, there was 40 plus services in AWS that are AI centric of the 330 plus services in AWS. Identity and those 40 services still a concern, or is this primarily a Bedrock issue? Should I be concerned with all of the other non-humans and humans that are running around with access to all the other 40 AI services, or is that a solved problem?
It's definitely not a solved problem. And, I mentioned it briefly earlier, but the reason we focused on Bedrock is because AI infrastructure has been the hot topic these past few months, but all of those other services are still a concern. Particularly with stuff like Q and SageMaker, you've got workloads running Gen AI with identity. You've got compute environments with identity where users with access to those things can start leveraging those permissions for themselves. SageMaker has had, known problems for years where if you don't control access to, the pre-signed URLs for the right notebooks, all of a sudden you could potentially have, third parties or unauthorized identities coming in and leveraging those permissions. Identity is definitely a problem kind of all across the board. Solving least privilege is a tale as old as time when it comes to cloud. And that's true for all of the AI services that exist, even the ones that are years old at this point.
Absolutely. And now I'll ask a plant question. Obviously, you said it. I love the way you said it. Asking developers to solve for least privilege. Yeah, I wish it was that easy. We know it's not that easy. The clouds we see day in and day out. You showed us a few examples of SCPs that can help. How do I effectively do this, Nigel? How do I actually handle the fact that in some of our customer environments, there are hundreds or thousands of identities associated to AI workloads and non-AI workloads that have the plethora of everything from EC2 star to, you know, mixed and matched permission sets that don't actually match what these workloads do. How do I solve this problem effectively for AI and non-AI workloads?
Yeah, and you know, there's a couple of ways that you can approach it. We looked at SCPs before, and you know, you can try and scale that up. You can build a team. You can go and, you know, be really clever with your SCPs and do things like blocking access to the services that you don't use, or you know, restricting access to specific resources to one or two identities. But as the number of identities in your cloud scales up, that becomes a little bit unfeasible. It gets to the point where you're going to need some sort of solution that is actually monitoring what is used within your cloud, so that you've got the intelligence to be able to make those decisions about what you're including in your controls really, really easy.
Are you saying the firewall?
I think an automated solution that can deal with all of that, all of those access concerns, knowing who uses what, knowing what behavior is normal, and then putting out some sort of guard in place so that when anything privileged is attempting to be used for the first time, you know, you've got you know, a request flow around that, so that you know when something is happening and, you know, have the ability to block something privileged. So yeah, I think the firewall is a perfect solution for this type of case.
Excellent. Well, I want to close it there. We've already taken 42 minutes of everyone's time. I do want to thank everyone for coming. Hopefully you learned something today. If it's as simple as, wow, that agent core is an interesting thing, I might want to look into that, to hopefully when you do look into it, looking at how you can secure it and what the implications are of having things like this run in your cloud environment, then this has been a win. So thanks everyone for coming. Hope to see some of you in trials and whatnot in the near future. Thank you again. Enjoy the rest of your day.
Thanks, folks.
You have to.
Yeah.